Thank you, everyone, for joining us today for our webinar, Architecting AI That Banks Can Trust, Why Knowledge Graphs Are the Missing Layer. I'm Victor Lee, your host. I'm head of product marketing here at TigerGraph, and I'm very pleased to be with my guest again, Rohit Chauhan. Rohit Chauhan was a longtime leader executive at Mastercard, most recently as the executive vice president of both AI and fraud. Rohit, welcome again.
Thank you.
So last time we sort of focused our discussion on fraud, and today we're going to focus a little bit more on AI. And, in our conversations, we've observed, like everyone else, that there's some wonderful stuff that's been happening with AI, but there's also, you know, areas where it's not working. And for businesses, having a certain amount of trustworthy reliability is essential. So maybe some businesses have paused or given up. Others seem to be succeeding. What is it that you have to say about this area? Is AI doomed to have limited success, or is it just a matter of learning to do it right?
So, Victor, that's a really good question, and I think we need to first kind of step back and look at something a little more, a much more fundamental question. So, what AI has done is that AI has come up. It's a technology that allows you to make predictions very accurately and very quickly that are scalable. And then, as a result of that, the business challenges are now being reframed as a prediction problem, and we're deploying AI to help solve them. But just imagine if you were to deploy an AI solution that gave you the right answer, 50% of the time randomly, then can you really have the confidence on kind of using that prediction to make um, business decision? The answer is no. I mean, like, no business will or no business leader will take on and deploy an algorithm that is 50% of the time right and 50% of the time not right, and that too, it's erratic. Like you don't know when it's going to be right and when it's not going to be right, or when it's going to be wrong. And I think most of the time, people very quickly kind of zero in and say that, this AI algorithm doesn't work. But I'm not 100% sure if it is the AI algorithm that's not working, or the data that has been used to train the algorithm was that complete. You want to make a prediction, but you need to
Mhm.
give the right ingredients. And if those things are not fully fleshed out, then obviously, the AI algorithm will provide partially good results, and it would be erratic.
Okay, so you got to have the right ingredients, the right inputs. That reminds me of an adage that we use with fraud prediction. Quality in, quality out, garbage in, garbage out. Did you when because you also well, we're also responsible for fraud. Did you have some of the same thoughts when you're thinking in the fraud context?
So, Victor, the answer is yes. But it's not just about good quality in, quality out, and garbage in, garbage out. It's also about the completeness of the
Mm,
picture.
hmm
I mean, even if you give extremely clean data, but you're giving a partial picture of the situation, of all the inputs that an AI algorithm actually needs to make a prediction, then it's going to be partially correct, but it will not be correct because it doesn't have all the totality of, all the things that it needs to evaluate to make a good decision. So
hmm
while I as much as I am a proponent of making sure that, you know, that the data should be clean and good and so on and so forth, the completeness, I'm underscoring the word completeness.
I got it. Okay, yeah. So clean, maybe the analogy of garbage and quality was suggesting too much about data cleanliness. Are your facts right? Um, but you're saying it's not enough to just have facts that are correct, but you need to have a complete picture. What is what is sufficient to answer this question? If you don't have enough of the right information, you're not going to be able to answer the question.
Yeah, Victor, if I have to give you like a quick analogy, assuming if it's a self-driving car and the car had just one set of cameras that are looking forward and nothing to understand what is on the sides or what is behind the car and so on and so forth, it's not a guarantee that the car will not have an accident because, you know, a lot of times things happen from sides, you know, and so on and so forth. And yeah, it would be right. You know, the car will not have an accident if there's nobody on the road and it's just moving straight. But if there is, you know, traffic congestion and there's a whole lot of things happening in and around the car that the car is not, you know, aware of, the self-driving car will have issues.
Okay. So needs that visibility. So um, the information has to be there and then it has to be observed, gathered, made available to the analytics system, right?
Yeah.
So, and I think we've hit on something important, something we want to remember that you need complete information. You have to have that 360 view, so to speak. And what's 360 is probably context dependent itself. So not every problem requires the same data. What is that? That makes me think a little bit about these models that we have now. We have some incredibly powerful LLMs out there. Probably when you started and you were telling me a little bit how long you've been doing this, but so it's just in the last 5 years, 3 years for the general public, things have changed radically, where they're now these um, available to the general public, incredibly powerful foundational models, as well as some specialized ones. Um, Even with those, people are still struggling sometimes to have successful AI applications. Where where's the gap?
So, Victor, that's a really good question. You know, in the past, AI has been here, has been around for many, many, many years. But only now, you know, you see AI adoption, you know, just totally taking off. And it's primarily driven by the fact that most, if not all, the major AI technologies are all available in the open source community. I mean, anybody can kind of get access to these technologies. In the past, you have to kind of hire, you know, PhDs, you know, who were specialized in building AI algorithms and so on and so forth. And hence AI was kind of very tightly kind of monopolized by very large corporations with, you know, with deep pockets and huge resource sets. So with that said, the technology has just been commoditized. Everybody has access to the same LLMs and, you know, and so on and so forth. Yeah, there may be some shades of difference between LLMs where they may have the latest model and, you know, and people may not have the latest model, but nevertheless, the technology is, you know, these are rounding errors that are not going to, you know, to make a very dramatic difference, you know, at least to most applications. But with that said, I think more fundamentally that if the technology has been commoditized, the engine has been commoditized, what exactly then becomes the key differentiator between one corporation and the other corporations? Like how do you compete if the engine, if every car is, you know, running the same engine, like how it then data just becomes the only source of sustained competitive advantage for these corporations. Like, I mean, it is the fuel that you're going to put in the car that will just and how sophisticated is your fuel, how complete is your fuel is going to then make the distinction or become the source of your competitive advantage, how you differentiate yourself, with other corporations and so on and so forth. And when you have the data then is, how complete is the data? How are you taking a partial picture or you getting the complete picture? Are you combining everything so that you understand the full context of what is going on rather than looking at a partial picture?
Hmm. Hmm.
So, so, so data, then becomes the key differentiator and getting, understanding the data from every angle, from every aspect, and every insight that you can draw from the data becomes more and more important. As I just mentioned, the data is your only source of your competitive advantage. The tools are exactly the same from one corporation to the other.
So is for businesses that you're familiar with, your own industry, banking, maybe some others that you've worked with, what are some of those types of informations that people should be paying attention to?
So, Victor, you said earlier in the discussion that the data set that you need to solve different problems are going to be different. I
Hmm.
mean, if it's a car running on the road, self-driving, it needs cameras on all sides and so on and so forth. But if you're trying to optimize fraud, you're going to, you'll look at a totally different data set. So the question then becomes is that fundamentally, if you're trying to make a prediction leveraging AI, you have to brainstorm like what are all the different dimensions of data that you need to be able to optimize that particular prediction or to get the best possible prediction. What are all the different data sets that you need? And for most parts, this data is never available from a unified single source. It's a lot of different data sets that are sitting all over the place that completes the picture. Rarely, when you're trying to solve complex problems, that there's one small data set collected from, the camera from the front of the car that makes all the decision. You can't. You need a lot of different data sets that are collected from various different parts of the organization and that combined together will then give you the ingredients to be able to make predictions that are reliable, solid, and can kind of, and can gain the trust and the confidence of the corporation that you can start making decision based on the predictions that are being made, leveraging, this unified data set that I was talking about.
Thank you. So one thing that we've been talking about here at TigerGraph is connected intelligence. And and so as you mentioned, the need to have this complete set of data. And again, what that means is somewhat application industry dependent, but it can you can I suppose come realize things that you didn't realize before. But I how is it sufficient to say, okay, I've identified these data sources. I'm gonna feed them all into my AI system. Um, will that be enough for the AI to understand, to be able to digest the facts and to reason with it? My sense is that's still not quite enough.
So, Victor, rarely do any mm, any algorithms that you build ingest raw data.
Hmm.
It's always a level of feature engineering that is done that creates, the relationship, the relationship, and the context. What exactly are we trying to, what the situation if we're trying to predict, what kind of, backdrop does it have, and so on and so forth. These are all derived intelligence, derived insights from the combined unified data set, which become the key ingredients going into an AI algorithm. And so having clean raw data and complete clean raw data is probably a starting point. But then building the features that are critical, um, to help, solve, to make the prediction model, much more powerful. That engineering, the feature engineering aspect, takes center stage. And that's what differentiates, again, from one deployment to another.
So one type of feature is actually the relationships between things, and then from that you can build additional features. So at TigerGraph, one thing that we do is we help companies model their data as a connected structure, as a graph, which itself answers some questions. And then from that, they can do additional feature extraction, which would not be available if they had flat data. Um, is this a technique that you were familiar with at Mastercard? Did you leverage this graph approach to connected data?
So, Victor, you have to understand that if you connect, most of the time, analysis historically has been done connecting the data longitudinally. If you take a customer and says, what has the customer done in the last 3 months, 6 months, 9 months, 12 months, and so on and so forth, and you create these longitudinal kind of time series, and then you find predictive, you build predictive model to see their acceleration or deacceleration of spending, or whatever the case might be, or behavior in certain categories, and so on and so forth. But these time series, where time series kind of, analytics, or time series feature engineering, can never capture spatial aspect of the relationship. So while, you may be using the data that you already have, that you connect in a time series fashion, but if you were to represent the data in a graphical form, then you can start building features that are spatial in natures, and they pop up new insights which will not be visible, or will not be which will not kind of come out doing longitudinal studies. So it is very important that not only longitudinal kind of features be built, but spatial features be built, leveraging graph technologies, which not only allow you to make the connection or connect all the different data sets together, but also allow you to do spatial feature engineering, and you kind of create node level features, which again add to the, to higher level of predictability or more stability in AI models.
Great. So um, I think what I'm hearing is that with maybe traditional tables, you can model one type of relationships, like longitudinal time series. But there may be spatial, there may be, and when you say spatial, do you mean like geographic, or is it something more general than that? Because I can imagine other types of relationships.
No, it's not just geographic. Geographic is one dimension of spatial. But you just imagine if you have, I mean, the whole world is a connected, whole world is a connected universe. People are connected to the families. Their families are connected to certain sort of merchants. The merchants are connected to other customers and all that. In a longitudinal, kind of relationships, you can't do any hop analysis. Like what is one hop away, but if you're doing kind of, and if you're representing your data in a graphical form, you can say, one hop would be a merchant, that you're connected to a merchant, but two hops would be, you're connected to a merchant, but the merchant is connected to another merchant or another customer. And there is some aspect of that kind of that bleeds into a feature that would never get captured within a longitudinal study. So the features are not just geographic, but they can be relationship based features, and how many nodes are connected to a particular, how many edges are connected to a particular node. All those are important aspects of graphical features, which are not kind of geographic in nature, but are very, very important nevertheless.
Great. So I think we're seeing that, just to recap, that we have wonderful models that are sort of democratized that aspect, but each business needs to pay attention to the data it's gathering and collecting, and to make it connected in a way that it can serve all the types of analysis and the types of reasoning that's needed. I'd say with machine learning, there was a lot of a structured uh, analytics. As we move into AI, there's a little bit more agentic reasoning of providing the AI with an information source, and it can take some initiative in deciding what question to ask. And I think that's what knowledge graphs are able to do, that they provide that sort of structured information store, relationship-based information store, and then the AI can query it to gather the context that it thinks it needs. Um, there wasn't really a question there, but do you have any comment on that?
Um, Victor, I totally agree that as as I'll tell you what um how agentic AI kind of makes make this kind of um concept even more important. So like if you're talking about, agentic AI in a commerce space, you want to create an agent that will go and make purchases, leveraging your credit card to whatever purchases you want to make, and you give the specification. At that point, you're already trusting your agent to actually make a physical transaction that would be built on your credit card, based on the criteria that you have given, whatever the case might be. Now you have at that point, you're trusting the agent to be able to make the right decision, and the decision that you are confident about. And if you're not confident, then you probably will never make the leap of actually using an agent to be able to, or even deploy an agent that you think may give kind of partially good predictions, and half the time it will make bad decisions and make bad purchases or whatever the case might be. So the completeness of the data, and being able to make consistently good decisions over time is what becomes the foundation of the agentic AI, wave that we are seeing, and to be able to make that consistently good prediction all the time, 99.99999% of the time, you have to have access to a complete data set and the context, and so that you have all the ingredients to make the decision.
Great. Thank you brought that back to the trust issue. So thank you for that. Now, let's say a business has done their homework. They've prototyped something in the lab. They've got their data. They have they've set up their test questions. Seems to have good degree of accuracy. Um, Now they want to roll it out to production. Is is there anything they should be looking for? Any what are the what steps would you take to make sure something it can successfully go into production?
So, Victor, there are like two things that I would highlight at this point. One is that you may have all the test cases that that you may create and so on and so forth, but there's nothing like testing your models in a live environment in a pilot form, so that you want to make sure that you didn't have any blind spots in kind of building your test scripts, or things that you never thought through that may pop up. So that's one dimension to it. The other dimension to it is that when you are building it in a lab, or building it in your kind of ecosystem, you can cobble together the data that you need, and you can join them, and create this Uber data set that you need, which is multidimensional, and it provides all the insights that you need to make all the right decisions, very accurately, and in a very stable form. But when you're taking it into production, this joining of the data and the creation of this Uber data set has to flow seamlessly. It can't be like eight analysts are trying to cobble together this data set that was used to build the model. It has to seamlessly flow in, because in most production environment, you get like literally milliseconds to make the decision,
Mm,
and you would never have the if all these things, all the combining this data set and then creating this information that I spoke about, if it is not totally productionalized in the architecture, then this is going to be just a lab, tested environment, and it will work, offline and so on and so forth, but could never be able to take into production. And I don't know if that answers your question, but it has to be kind of, it has to be done at a much upstream kind of stage, so that all the downstream applications can kind of leverage this combined unified information. And as I mentioned, that if the data is the only source of your sustained competitive advantage, then this issue is really important, and you need to kind of to pay serious attention in doing that, because not just one application is going to leverage this.
mm.
Almost every application that gets spawned out within a corporation or within a company is going to benefit from this particular ecosystem.
Right. Now, actually, you hit on something that maybe not everybody. I even though you said it to me before, it still resonates strongly with me as though even though I come from, I work for TigerGraph, but I just when I hear somebody from industry saying you've got to have that data pipeline set up to, it has to be architected for the requirements, it really hits home. So just to reiterate, what struck me is says you can cobble together the data for your proof of concept, but that's not what you're need to actually do in production. In production, you have to have a pipeline that's going to bring together the complete contextual data in with the timeliness that's required for the application, whether that's milliseconds, whether that's, 1 second, I guess it depends on the application and how many users you would have, but you can't cobble it together. It has to be just part of the pipeline.
Correct.
So, and again, so now banking is a highly regulated industry. Where did things like, compliance, audit, and, explainability fit into your your sort of design requirements? How would that have affected your that data orchestration?
So, Victor, like any AI model that gets deployed in the financial services ecosystem, which is an industry that is highly regulated, um, you have to be able to defend your algorithm and show the traceability of exactly what led to to what led to the prediction and how you can defend it. Now, it is, and I'm just giving you a very hypothetical example. There are algorithms that we can build, throwing a lot of things into the kitchen sink that may be very, very predictive. But we, for the life of us, we will never be able to explain exactly how the decision was made. And those are the algorithms that we will never be able to defend or deploy.
Hmm.
So having things like a graphical structure where you can trace the data sets, the features, what exactly led to that, just allows you to increase the palette of ingredients that you will be able to use. Otherwise, if it is like, five times, combining features creates more engineered features. Like you can keep going deeper down into a nest of features, which then becomes like you totally lose control of explainability. But this allows you to have much cleaner set of features that are very defendable, which allows you to build models that are predictive and explainable at the same time.
Great. So I think we're getting a pretty complete picture here now. So that we can have trustworthy systems, but it requires, careful development work, including having complete data that can be productionalized, um, that complete data that shows you relationships, because that's a key part of information. Um, Maybe, the last thing is, are there any particular areas? Well, so how would you sort of wrap it up with advice you would give to a business leader who's going down this road of trying to, find the right AI to deploy?
So, Victor, if I was to summarize, everything that we have discussed in the last half hour plus, is that people have to fundamentally understand and accept the fact that their proprietary data is going to be the only source of their sustained competitive advantage. Everything else, like the infrastructure, algorithms, I mean, everybody has access. Everything else has been commoditized. So I think that part you have to first start with and say is that that is a common ground, common understanding, and a ground truth. With that said, we all understand that data gets collected in various places within the corporation. It's not just one unified place where all the data gets collected. It's collected in various forms. If data is the only source of your sustained competitive advantage, you want to make sure that you're getting the insight from the connected intelligence if you were to connect all the data together, because it is clear that the intelligence gleaned from the combined data set is going to be more than some of its parts, because you don't get the context by just looking at a small piece of information. And hence the connected intelligence becomes extremely important, not just complete, not just insight from individual siloed data set, but the insight gleaned from connected data set. So that is the second point I would make. The third point I would make is that while you are able to do this connection and all that, for any serious algorithm to put into production, you need to make sure that these connections and pipelining is done at an architectural level so that these are not like projects where these are done in batches and it and it gets updated. All these things have to come together at at the right time in a near real time kind of um, sort of ecosystem, so that your decisions can be made accurately at the right time so that you can affect the business bottom line.
Thank you, Rohit. I really enjoyed this. These are always very enlightening conversations for me. I hope they are for our audience as well. If there's anyone out there that has a question, please post it on our Q&A. We'll give you a few minutes, but I do have a few follow-ups for you, Rohit. Um, I guess I'm thinking this is sort of a fun question. Are there any AI applications out there that you've sort of been using in your personal life that you think are just a great piece of engineering?
So Victor, I mean, I have to tell you that I do have a paid subscription of both Anthropic and ChatGPT. And often I kind of ask the same questions to both of them to see which one comes back with a better answer. And I mean, that fundamentally the technology is the same. I mean, they're using, but from a fine-tuning perspective, they're fine-tuned differently with different philosophies and all that. And I find it amazing, interesting that I couldn't quite pick a winner yet. Like, in certain things, one will do better. At times, the other will do better. Sometimes I'm surprised that, both of them are giving me bad answers, kind of thing. But it's very enjoyable to test it, in a, head-on kind of head-on test.
Well, that actually points to a common machine learning technique on ensemble models where you don't put all your trust in one model. You actually build a couple ones which maybe have tuned slightly differently, and then you sort of take an average or you do a quorum answer to pick your final answer.
Right, right. Victor, there was like an interesting kind of interesting point of view, and the point of view was that a question that often I would get asked was that what do you see as the limitations of AI? Like, I mean, if there were any limitations, what would be the limitations of AI? And I strongly believed that, the biggest limitation of AI is going to be our own imagination.
Mm.
If you think small, you'll do small things with AI. If you think big, you will do big things. And and as much as I kind of believed in it, but now with the LLMs and so on and so forth, I feel that you really don't need to be an extremely savvy programmer to be able to dream of something and bring that to life. You can,
Right.
you can still leverage, your or pick up, a little bit of your, programming skills and still leverage these LLMs to solve complex problems. Like, I've created spreadsheets where I'm running like Monte Carlo simulations and, which would have required me to do like major programming, but I'm just
Mm.
putting stuff on spreadsheets and running, simulations of like, 50,000 iterations and getting P10, P50, P90s, and a whole bunch of things which, if I can think of it, I'm able to do it.
Yeah, it's amazing. We do have a question from the audience.
Okay.
Um, these types of applications have zillions of records. Not sure how many zeros is zillions, but it's big. How do you manage graph scalability? So I think I'll answer that first from the TigerGraph product side, and if you'd like to answer something from the system side, I'll let you do that. So as a platform, TigerGraph is specifically designed for enterprise scale. It's distributed database with massively parallel processing, compressed data storage for more compact footprint, and it's just been demonstrated with a lot of established engineering techniques actually from other database earlier designs, distributed processing, but applied to graph concepts. We've been able to make the type of multi-terabyte database that large institutions like Mastercard actually use in production. Um, Now, maybe from the user side, do you have any comments about, how do you actually think about or manage a very large database like that,
So
Rohit?
Victor, this is a really, really good question, and I commend the person who actually asked this question. So, like, networks and certain banks and all that literally get like billions of transactions on a single day or a single weekend. And trying to kind of flesh out a graph with, all those things together, creating nodes and edges and all that, can be a monumental task. So when we were kind of studying these, graphical features and all that, we discovered that the whole bunch of graphical features, at least a set of graphical features, important graphical features, were not very fast moving. And from time and hence we seriously looked into certain, we did a study on which were fast moving and which were not so fast moving, and those that are not fast moving, very well could be done, using a different kind of, cadence.
Mhm.
But for those that were fast moving, we heavily researched into graph sampling. Rather than using 100% of your data to actually flesh out a complete graph, you should be able to flesh out a very working graph with, especially where there are like, zillions, as you mentioned, of edges kind of popping up very, very quickly. There are very advanced graph sampling methods that are out there that will allow you to still flesh out a graph and still draw
Mhm.
insights without fully developing or fleshing out the complete graph.
Okay. So I think you have to have the raw data, and you construct as much of the graph as sort of the is necessary to keep up with the development cycle, and then also maybe not every feature is extracted in real time, Some are, and others that evolve more slowly can be computed on less frequently.
Correct.
There are a couple more graph performance questions, so we'll still try to address them. How do you address disaster recovery? And there's just a general question about graph latency. So, TigerGraph does offer both real high availability, both region within the same region. We can have multiple replicas of the data that are in sync. So, in case any particular resource becomes unavailable, there's another resource within the same region. But also we support cross-region replication and disaster recovery, which I think would be very essential for a business like Mastercard, where it can never go down. At least for the things related to its operations, as opposed to, there's also some offline analytics, but the operations can never go down. Um, so is that a feature that sort of you designed into any of your operational graphs?
So, Victor, like if you put anything into production,
Yeah.
you need to have, all the things that are being discussed because, you can't, I mean, there has to be fault tolerance no matter what happens. So like any large corporation, every corporation will have multiple kind of um, strategies to compensate if there is a breakage of any form.
Yeah, and lastly, there's just sort of a general question about, let's see. I think we'll kind of skip the graph latency one, because you mentioned briefly that you needed answers in milliseconds, and then, for the task that you chose the graph to serve, it obviously was able to do it.
Yep.
Otherwise, it wouldn't have gone into production. But there's a question about, do you break the graph architecture down by region? That gets an interesting question of I think data residency, and what do they call that? There's another related concept, but I know some countries have regulations now where the data cannot physically leave their country. Um, do you have any sort of non-proprietary things you can say in general about that?
Yeah, so raw data cannot leave, um, certain on soil, there are some on soil requirements and so on and so forth. But insights um, are much easy to transfer and are much more because you just you're transferring features which are not raw, which are not kind of raw transaction data or any data. And I think what one has to understand that these features are being used to score the transactions for the consumer on that particular soil.
Hmm.
So, sometimes the way these are managed is that the algorithms are being deployed on soil to be able to then have access to the information that is being gathered within a particular region. But I think I'm going to just divulge a little bit, like deviate a little bit on the question. So one has to understand that it's never that you connect the data sets that you have in a single graphical structure. Sometimes the problem that you're trying to solve dictate that you may use the same data to create graph that have a different structure, even though the data might be the same.
Hmm.
And so it's not that, sometimes it's that you create this, Uber graph kind of thing, and for most of the time that works. But then there would be times where you would want to create a subgraph which is very problem specific for a particular issue that you're targeting, and then you kind of, you kind of hone into that.
Okay. So there you may have different graphs for different use cases,
Correct.
um, but those same use cases may exist, say, um, across multiple regions. So
Yeah.
it's probably more by there. You said obviously because you have to, you always comply by any, data on soil requirements,
Right.
but derived data insights can cross lines.
Yeah, it's like, I mean, the concept is any corporation that is, working across the globe, the concept of federated learning, like, you may not move the data, but the learnings from that particular
Hmm.
region can flow out, so that when you're creating an ensemble model, you're kind of just, you're leveraging the insights so that you understand the nuances of, that particular region in a way that you're complying with all regulation at the same time, and not creating blind spots for an algorithm that is going to be deployed globally.
Yeah, I'm glad you brought up federated learning. I didn't want to be the geek that did that, but that if you just think about for the audience, a machine learning model uses a lot of sort of synthetic variables, which so those don't belong to any real person. They're synthetic, but they're essential to training the model, and those can cross. So the part of one thing about federated learning is the different sites can share these synthetic variables to train the ensemble model, but no proprietary information is being transferred. So I think we're at about time. So again, I think we've had a really interesting conversation about building trust in AI, building first of all building success, and trust being part of that, needing the right data, and then you know orchestrating that data with the right connections, um, to give the AI the context it needs to build those trustworthy answers. So again, I want to thank my guest, Rohit Chauhan. Um, we've been talking about topics that are in this ebook, Architecting AI That Banks Can Trust, Why Knowledge Graphs Are the Missing Layer. That ebook should be available from TigerGraph's website now. If you just go to our resources page, I think you'll see it there. And if you'd like to try TigerGraph in one of our solution kits, you can try it for free at tgcloud.io.